We're going to take a look at the measures of variability for this very small data set. So if you notice, this data set has just a sample size of 4. We're specifically going to look at this as a sample size. So the first measure of variability, if you recall, there are 3, but the first one is the most simplistic, which is the range. So we're going to take a look at the range and just see, as simple as that, and we're not going to do the real range, it's just going to be the straightforward range. There is no notation, so the range is just basically the highest number minus the lowest number. Okay, so in this case, we end up with, 6 is our highest number, 3 is our lowest number. 6 minus 3 is basically, we have a range of 3. That's our final answer. It's as simple as that. That is very much the simplest form of variability. All that's telling us is that our range of numbers is merely a range of 3. It could differ on many extents. If I had an exam and the possible range before anyone takes a test is anywhere from 0% to 100%. But if once I do get people to take the exam and I tell you, well, on the exam the range was 20%, 20. That means that it doesn't tell us whether that range was high or low necessarily, but it tells us quite a bit that there was a cluster of scores. They were clustered pretty close together. That's all it tells us. It's a very rudimentary measure of variability. The next measure of variability that we'll talk about is variance. And I'm going to erase this because variance is going to take us a little bit more space and just a little bit more time and effort. So again, measures of variability. The first one is range, and then we'll go into variance. Sounds like variability, but it's actually a very specific measure. And specifically, we're looking at variance, and since it's a sample, we're going to use our notation, which is a small s and the squared symbol. Okay? Now, our equation for variance is basically the sums of squares divided by degrees of freedom. Now, both of these numbers, or both of these notations are within this equation, they're merely notations prompting us that there is actually an equation. So let's break it down a little bit more, and we're going to look at what the specific equations are. So I'm going to kind of color code this so that you can see a little bit better how this is working. So I'm just going to take just this sums of square. So pay close attention. I'm going to drop down here. Sums of square is merely a notation, but its equation is the sum of x squared minus the sum of x total squared divided by n. Now that n in this case is either sample or population. That is usually interchangeable, but in this case we're dealing with a sample. Now, to be able to get this sums of square, we're going to have to do some things. To get our sum of x squared, we're just basically going to square each of these raw scores separately. So we're looking at, 16, 36, 25, 9, and we're going to add those together. That is what the sum of x squared is. Without those parentheses, remember if you're looking at order of operations, you're going to square every x before adding them because exponents come before adding. So our sum of x squared, if we add these up, is 86. Okay? Now, for this portion of the equation, this sum of x total squared, and I'm just going to give a little highlight here, this right here, we have to pay attention to our order of operations. Remember, parentheses comes before exponents. So in this case, we're going to just take our sum of x, just add up just these original raw numbers, the very, very first numbers without squaring them or anything. So that 4 plus 6 plus 5 plus 3. We should get just a sum of x equals 18. Then we can just start plugging it in. So in the end, our sums of squares ends up being 86 minus 18, we can put parentheses around it, squared, divided by 4, because our sample size is 4. Okay? So when you plug that into your calculator, be very careful that you're doing things in the right order, because that second portion, I'm going to highlight it, that second portion of that, this is a separate standalone fraction that you're going to subtract from the 86. So be very careful that you're plugging things into the calculator appropriately. When you do total that up, your end result should actually be 5. Now that's just our sums of square. Okay? That just resolved that. Just that. Okay? So I'm going to go ahead and erase a little space here so that we have enough room to actually finish our equation. And I'm going to make sure that we are able to see what I'm doing here so that you can see how this works. Now we're going to work on the final equation, but looking at degrees of freedom is literally n minus 1. So I'm going to draw a little arrow here, n minus 1. And n is sample size. That's simple. 4 minus 1 is 3, right? So here we have 3, okay? And we're going to look at the equation. That's in our denominator, right? And we have our numerator, 5, right? This is going to be our variance equation. That's all this is. S squared equals. Now, if you plug that into your calculator, 5 divided by 3, you should get, equals 1.6, and it's repeating 66666. We're going to round to 2 decimals. So it's 1.67 is your final answer for variance. So variance is just some steps that you kind of have to go through. First, you have to really know your notations to be able to get that. Okay, we're going to move from variance, though, to our next measure of variability, the third measure, which is standard deviation. Now, I'm going to leave most of this, but I'm going to erase some room here so that we can kind of get an idea of where we're at without totally losing track of things. So we're going to erase this so that we can have some space to do some work, although there's not much work left after we've got variance, because our standard deviation is very simple. Standard deviation, if we look at the actual equation, and I'm going to write this out, I'm going to put it here in a little bit brighter red. standard deviation, and I'm going to use this SD. I'm going to erase this so you're not getting confused thinking that's sums a square. So it's not. Standard deviation. Standard deviation is basically sums a square divided by degrees of freedom, but all of that under square root. Okay? So if we really look at this equation, this all, and I'm going to highlight here, all of this is the same thing as this. So if you do all of this on the same data set, you should get basically this, but without the square root. So if we kind of look back easily here, it could also be standard deviation also equals the square root of variance. So for our case, we could do this. Standard deviation equals the square root of 1.67. If we get 1.67, take that square root of 1.67, we should be getting 1.29. 1.29. Rounded to 2 decimals again. So we got our range, which was 3. We got our variance, which was 1.67, and now we just got our standard deviation, which is 1.29. Now you try it.